Hi, I'm Professor Deb Stockbridge, and this PowerPoint presentation is based on the 6th edition of Absolute C++ by Walter Savage, published in 2016 by Pearson Incorporated. This presentation is for the C++ programming class at Quincy College, but all are welcome to view it. Chapter 6 covers classes and structures. I've divided the PowerPoint presentations into two parts, one covering structures and one covering classes. This presentation covers structures. A structure, also known as struct, is an aggregate or grouping of values of different data types. They are treated as a single item, like an array, but are different because arrays will only have one data type for its elements. Both an array and a struct are defined globally before the main function. You define the struct before you declare any variables of the struct. No memory is allocated for the struct. It just shows what the struct looks like. When variables of the struct are defined, then memory is allocated for the struct variable. This slide shows an example of a struct. The name of the struct is bank account. Naming a struct uses the same rules as naming any other identifier. There are three members of this struct: balance, interest, and name. When a variable of the bank account struct is created, it automatically has a balance, interest, and name as part of the variable. Notice that the second curly brace for the struct has to have a semicolon after it. In the previous slide, we saw how bank account was defined. So that's on the left. When you create a variable of the struct, you use the name of the struct, which is bank account, and then the name of your variable. So this first one is checking. So checking automatically will have a balance, interest, and a name. And then the second variable that was declared is savings. And you declare it by using the name of the struct, which is bank account. And that also will have those three variables, the balance, interest, and name. The dot operator, or period, is used to access the members of the struct. This way, you can change the values of balance, interest, and name for the checking variable and the savings variable. So on the left, you see the definition of the struct bank account. Over on the right, you can access balance from the checking account struct variable by saying checking.balance, checking.interest, checking.name. If you created another struct variable called savings, you could access the members of that by doing savings.balance, savings.interest, and savings.name. So at the very bottom of the slide, it shows a portion of a program where you ask the user to enter the balance in the checking account, and then whatever they give as a value is assigned to checking.balance. There are many programs in the book that will need explanation. This is one of the first ones that I'm going to be talking about. This is Display 6.1, and it's on pages 247 through 248. I've taken the important parts of the program that's on page 247 and 248 so that I can explain them to you. So this is a complete program. So the first thing you want to do is pound include IOStream, then using namespace std, and then you have the definition of the struct. The struct's name is cd account v1, and it has three data members: a double, which is balance, a double, which is interest rate, and an integer, which is term. And remember the semicolon after the last curly brace. Then we have a function prototype. The name of the function is getData, It's a void function, which means it doesn't return anything. And it's receiving the address of one of the variables that's been created from the struct CDA account v1. Okay, and then remember, function prototypes have a semicolon at the end of them. And let's skip over to the right-hand side, and this is the definition of the getData function. So notice that the first line, which is the header in the function definition, is the same thing as what you have in the function prototype. So in the getData function, we have an output that says enter the account balance. So the person is going to enter what the balance is in that account, and it's going to be assigned to the account, whatever the account is that we're looking at, dot balance. It'll store it in balance. The next one is enter the account interest rate, and that's stored in the interest rate of the account. Then enter the number of months until maturity, and that's stored in the account dot term. Now in your function definition, the account that's up at the top in the header is just a placeholder. When we call that function in the main function, we'll be giving it a specific struct variable that we've created. But basically what you're doing in getData is it's assigning values to balance, interest rate, and term. So going back to where that is called, well, no, sorry, not called yet. That was the function prototype where we left off, where it's void getData and then the information of what's the argument and then semicolon. So our main function is int main, and we're going to call that, we create the something called, what's a struct variable called account. And it's from the CDA account v1. That's the struct, and it's kind of like the data type now of the account. Then it calls getData under that new struct variable called account that we did. So it goes over to the getData. It'll find out what the balance is of account, the interest rate for the account, and the months until maturity for the account. And then the last thing it does is it outputs what the term is by saying account.term, and it outputs what the account balance is by using account.balance. When two structure variables are from the same structure, you can assign the member variables of one structure to the other structure. In this example, the values of the data members of savings are changed to the values of the data members for checking. So whatever the balance is in checking, it's assigned to savings balance. Whatever the interest rate is in checking, it's assigned to the savings interest. And whatever the name of the checking is, it's assigned to the name of the savings. Structures can be function arguments. Structures can be passed by value. In this case, the function would receive a copy of the structure, but that's not used that often because structures take up a lot of overhead. Structures are usually passed by reference. The address of the structure is passed to the function. So in our example, the previous example of the function getData, we give the address of the checking structure that we have. And that's also useful because we're actually changing the data that's saved in the member variables for checking. We're setting a new balance, we're setting an interest rate, and we're setting a term. Structures can be returned by a function. So you could say return checking.interest, and that would return the value of interest of the checking account. Structures can also be initialized, which means they're given values. So on the left, we have our bank account structure with balance, interest, and name. And on the first line on the right, we are creating a structure variable called checking. and we put bank account because it's a bank account structure. And we use the assignment operator, and in curly braces, we list the 3 values for the 3 data members in order. So the first, the 123.45, that's going to be the balance. The interest is going to be 0.05, and then the name is going to be Farah. Now notice that the name is in double quotes because it is a string. Then below that, we create another structure variable called savings from the bank account structure. And we give it 3 different values. The first one, 50.67, is going to be the balance. The 0.10 is the interest rate, and the name is Todd.